So I have this grateful task of being the last person between you and drinks, which is pretty hard. But as it was mentioned, my name is Diogo Mónica. I currently lead the security team at Square. I currently lead the security team at Docker. My previous job was leading the platform security team at Square. For those of you that don't know Square, it's a payments company, pretty big in the United States, Japan, and Canada. Today, I wanted to talk about the security mistakes that will haunt your startup. Over the past 5 years, and by the way, notice the little ghost. It was 30 minutes of my life right there in the keynote. Let's do that again, just because it has to be shown twice. There you go, the ghost showing up. Today I'm going to be talking about, essentially, over the past 5 years, I've seen and participated and advised dozens of startups. And after a while, I started seeing some patterns. And these patterns were usually around security mistakes and some things that people were doing wrong. And today, what I'm going to go over is essentially an unordered list. So it's not in particular order, but of mistakes that I've seen people do that are really hard to fix later on, maybe even orders of magnitude. I would just like to put one caveat, which is this is not an exhaustive list of mistakes. Even if you go through all of these, you still should get a security person, a security engineer, because you can still get hacked, right? So just careful there. I don't want any liability. Oh, I did everything he said and I still got hacked. What is the target audience for this talk? So obviously, the target audience is small companies starting up, hopefully before you hire your first security engineer. But the reality of this is that every single startup will hit these mistakes. If you're growing, you will hit essentially every single one of these mistakes, and it's up to you how to react to them. Before I go to the list, I would like to point out one thing. This was actually mentioned by one of the previous presentations by Ryan from Etsy. There's this myth that security engineers are essentially the people that say no all the time, or the people that passive-aggressively send emails out saying, you screwed up, fix it, please. So the reality of it is that if you hired those security engineers, you did a bad job, you should probably get rid of them. A real security engineer ships. It's there with you to help you develop features and products and essentially ship them safely. So today, what I'm going to show you is if you do bring on a security engineer, you want one that helps you mitigate some of these mistakes that later on can be orders of magnitude harder to solve or fix. Perfect, let's get this started. So first I'm going to go over some TLS mistakes, which everybody in this room has made at one point or another. The number one mistake, and the biggest one, is not starting with TLS from day one. So this seems pretty obvious, but the reality of this is that I tell this to people and they come to me and say, Diogo, don't worry about it. My login page has HTTPS. And I'm not sure if to cry or laugh, but the reality is that even after 10 years of this, people do not understand that if you have one HTTP link on your page, just one, it's done. People can use SSL strip to essentially inject JavaScript, inject code on your application, and all of your passwords are gone. So if you do one HTTP endpoint, you're already screwed from the start. And this is not easy to do. It took Facebook 2 years to implement full TLS completely on their website. I'm going to, throughout the talk, have some terminals for people that have laptops, or I'm going to make these slides available so you can follow at home, and they're quick, dirty hacks for you to check some of these mistakes on your infrastructure on the terminal. Second mistake that is very common is, cool, you set up full TLS. However, you forgot to disable SSL v3. So you still think that it's just setting up the stack and you don't need any configuration. Unfortunately, this is not true. There's tons of attacks on SSL v3, there's Poodle, there's tons of mistakes, and this was essentially in writing for a long time. People tell me, Diogo, I don't want to disable SSL v3 because I have legitimate clients that use SSL v3. And then I ask them what legitimate clients are using SSL v3, and they usually point me to Internet Explorer 6 on Windows Service Pack 2. To which I say, A, Internet Explorer is not a legitimate client, but number two, the majority of those are bots. If you actually go see who is requesting these things, it's just a bot with a user agent that says, i.e. on SP2, it's actually not a legitimate client. So that is not an excuse, get rid of SSL v3. Even if you don't believe in what I'm saying, if you are at some point are going to accept credit cards, then unfortunately the PCI Council is actually cracking really hard on use of SSL v3. So if you want to be PCI compliant, no SSL v3 in production. And it's also a very easy check to make. So you can easily go through all of your endpoints and try to negotiate using SSL v3 and seeing if you're compliant or not. So you have TLS, make sure you disable SSL v3. And now that we have this TLS infrastructure, obviously to run it, you need certificates, which now brings the issue of which certificates? Who's going to be the issuer? Who's the CA for this? And you really need to choose the right CA. One of the biggest reasons for this is that if you're using an application, and nowadays everybody has a mobile application, you are going to have, or should, strongly consider pinning your application to this CA. Just so you don't have 300 CAs that can man in the middle your client, you should have one, or two, if you want to have some redundancy. What this means is that you have to choose them very carefully. In particular, there's one common mistake that is, thank God, getting less common, but you choose a CA that has an intermediate certificate with SHA-1, or your certificate has a SHA-1 hash as the fingerprint at the end. This is bad. Why? Because SHA-1 is known to be almost broken, let's put it this way, and browsers like Chrome are actually actively giving warnings to people, red warnings, big red warnings saying this is not a trusted website because it has a SHA-1 certificate. So you definitely don't want to not have your green icon on the top left of the corner. So make sure you choose the right CA, no SHA-1 intermediates, and your certificate is not using SHA-1. It's using something like SHA-256. Another thing that people tell me is that, okay, I went through all these steps, and so I'm secure, right? To which I tell them, unfortunately, no. So you are full TLS, you are using a good CA, you are not using SSL-v3. Unfortunately, the first connection from your client, if they're at Starbucks, it's still vulnerable. Why? Because they connect to an unauthenticated wireless hotspot. By default, some browsers, when you type the URL or the domain on the URL, try HTTP first, and then from that moment on, an attacker can just do DNS spoofing, redirect the URL, and then they're in control. So there is a fix for that, which is called HSTS, and it's essentially a header that you put on your browser and on your web applications that solves this. The first time somebody accesses a website, from that moment on, it knows that it always has to use HTTPS. So it somewhat solves the problem. Essentially, the attacker just can't get your client on the first time they access this website. And I'm using as an example HSTS because it's one of the biggest things that you have to be careful with. However, there's tons of security headers that you have to be concerned about. So really my recommendation is that you should use something like Twitter Secure Header Gem, or really build into your templates, your default application templates at your company, build these headers by default. So just when a new engineer comes along and, oh, I'm going to create an application, I have this Ruby on Rails template or this Django template, and immediately they have all these headers by default. And this is the way that you should be doing this in your infrastructure, because believe me, you're going to forget some of these headers later on, and it's going to be a lot more painful to fix it afterwards. And finally, really is that people are not used to managing these certificates or managing these infrastructures as they should. So really they don't care about monitoring, they let certificates expire, and a lot of, as I mentioned with the case of SSL-v3, a lot of the writing was on the wall. We knew that SSL-v3 was bad, but nobody really made a conscious effort to actually get rid of it. And it's only when something like Poodle and all this propaganda machine against SSL-v3 came around that people are actually starting to change. So if you keep track of this closely, you're actually going to be ahead of the curve, and just track your score. Like, we knew that SSL-v3 was bad. We were already giving bad ratings for it for years, so you should definitely keep track of your progress and make sure that you have A or A+ rating on something like SSL Labs test. Cool, so this is for TLS specifically. Let's go on to a slightly different vertical. Let's talk about web security mistakes. Biggest mistake that I see out there, there's a new startup. They create their own cool domain, and they're hosting content. Now, we were talking about CDNs. They're hosting user content. So they're a blog provider or something. Every single one of them just hosts the content in the beginning on the same domain as they host the main website. So they're not really separating using content from their own content, which means that stuff like cross-site scripting can happen on your website using user content. And it's really, really hard to start a website that has user content on the same domain and then later on switch it out. So be really cognizant of that one and be really careful with this one. Another thing that is really interesting that nobody really does from the beginning, and it's really painful to fix afterwards, is hosting all of your static files in a different domain. And I'm not just talking about images, so using a CDN for images, et cetera, et cetera. I'm talking about JavaScript content in particular. The reason why this is interesting is if you host JavaScript content on a different domain, it becomes really, really easy to implement CSP, content security policies later on, and really have your website on lockdown for web vulnerabilities. So it's going to save you a ton of time. It actually might be impossible later on, as I've seen, to actually go back, and people just give up if they didn't start from the beginning by doing this. And the final thing is that you should not be loading JavaScript content from an untrusted provider. Some CDNs that you trust, totally fine. However, you should not be linking a JavaScript just because some blog on the internet had some copy-paste code that, oh, this is how you link jQuery, and so you just include it without actually hosting it yourself. Any update to this JavaScript means full compromise of your website. And it doesn't really matter if you're using HTTPS or not. If I inject JavaScript on your domain, I can just tell the JavaScript to send the password somewhere else. So you should really, really be careful with how you include and where you include your JavaScript file, because one hacked JavaScript file, game over. Another thing that really comes from this is that people have cookie scoping as an afterthought. Nobody thinks about this in the beginning, and so nobody really thinks about having different domains. An example that I see over and over again is you have a startup, you have a website. In this case, I'm using my own personal website. You have diogomonica.com. And then immediately you want to have a marketing blog. So what do? You register a subdomain called blog.diogomonica.com. But the reality of this is by doing this, you just extended the trust of diogomonica.com to blog.diogomonica.com. So the moment you start asking for passwords and usernames on diogomonica.com, you're essentially screwed, because the security of your whole system is the security of your least secure website, right? It's the minimum common denominator. And the minimum common denominator, the blog, is going to be WordPress. Do you want to rely all of your security on the shitty WordPress blog that you have on blog.diogomonica.com? The answer is no. No, you do not. So you have to be careful with this, because there's tons of problems, cookie stealing, cookie eviction, session fixation that happen when you screw this up. And guess what? It's really hard later on to go to Google and change every single link on Google's index to something that is not blog.diogomonica.com. So make sure you don't get this wrong in the first time. And it might just be that the answer to this is that your trusted domain is not your main domain. So you have secure.diogomonica.com. What you can have is secure.diogomonica.com and blog.diogomonica.com, because then they're sharing the same trust domain. And this is not a security vulnerability. This is just how browsers work. So get it right from the start. I mentioned CSP for a little bit. And one of the mistakes that I see is people not knowing about it. So I would like to inform you that content security policy is really cool. And it's cool even if you are not using it in a force mode. So there is a mode called report mode, where you can have content security policy telling you, for example, where your JavaScript comes from, if somebody is inlining JavaScript, if somebody injected JavaScript from a different domain, and not actively block it. So you can have this on reporting mode, gather statistics, and really inform your developers if they're screwing up or not. Nowadays, people get to the point where they have so much JavaScript in line that it's impossible for them to actually later on put CSP in enforcing mode, because they've been doing the wrong patterns for so long. And to be honest, JavaScript frameworks don't really help, but they've been doing this for so long that they just can't go back. So this is one of those that it's going to take you years to solve later on, and it could take maybe weeks if you could solve it from the beginning, or at least be informed about it, knowing that it's happening, trying to make developers use the right tools and the right mechanisms. Another mistake that is kind of interesting is admin dashboards. So some frameworks out there are very, very cool, right? They just give you an admin dashboard just by magic, by the virtue of you having a framework. Django is a good example. You create a website, you have a model, and immediately you have an admin dashboard to manage this model. The problem with this is that now your admin dashboard is accessible to the internet. And this means that it's sharing the admin dashboard, this really important tool, is sharing the security of every single other piece of your website. So if you have a cross-site scripting on your website, it's going to share the domain with the admin domain, and cross-site scripting can attack admins and can leak cookies and can leak credentials of admins. So this is really bad, right? This is something that you don't want to do. So if you are planning on having an admin, you don't really need to have a separate infrastructure. You can still reuse Django. You can still reuse your tools and your mechanisms and your templates and your frameworks, but you should host it on a different VM, host, container, and you should put it behind a system that probably has two-factor authentication. A problem that I'm particularly passionate about is logging and mistakes around logging. And the reason why I'm so passionate about this is because I've wasted hours, weeks of my life trying to scrub passwords and trying to scrub sensitive data from logs. And this happens everywhere I've seen. It is really, really a really big problem that I really have not seen any good solutions for. But I would like to alert you anyway that from day one, you should totally use a whitelist model for what you log in your infrastructure. This happens all the time. You have your Rails app or your PHP app, and you are logging the data. And then you have a credit card page that receives the credit card. What do? You're going to log the request. So you log the username, you log the IP address, you log the time of the request. And then you don't log, or specifically say, do not log the credit card. Credit_card. Let's assume that the variable name is credit_card. Later on, a developer does a refactor and just changes the name of the variable from credit_card to credit card. If you had a blacklist, now credit cards are all over the logs. Good luck trying to remove logs from Hadoop. People were talking about using large-scale logging systems, but nobody managed to reference the fact that they're nearly impossible to scrub. Good luck trying to go through the indexes and trying to remove this data from each index and then seeing in which node this data is distributed to. We've made our infrastructure so resilient and so prone to not losing data that we cannot actually lose intentional data when we want to. So deletion is a huge problem, and you're going to deal with it, and it's going to be painful. So at least use a whitelist model instead of blacklist model for all of your logging stuff. Perfect. So these are some web problems that I've seen over and over again. So now let's go to password mistakes. These are particularly interesting. I would like to see a show of hands of the people that have seen secrets being logged into any kind of versioning manager, either GitHub or something else. So more than half of the room put their hands in the air, and the other half is clearly lying because this is something that happens to every single person that I've seen. The reality of this is that it doesn't matter if it happens or not. I've given up on this happening. What matters is how fast you detect it. I think there's an interesting story here, which last year I got called by a company that I'm advising, and they call me and say, Diogo, we have a problem. We've been hacked. I'm like, okay, cool, let me go in. I go in, we start looking at the logs, and what happened was somebody has hacked into their Amazon account, so their AWS account. So we start looking at the logs, and we don't see anything weird. And at a certain point, we see a legitimate API call starting to have a weird behavior. And immediately what I thought was, this pattern matches nothing except somebody had these credentials. And so we started looking around, and lo and behold, the credentials were on GitHub. The attackers came in, and in 2 hours, they spent $35,000 on machines in EC2. And the reason why they spent $35,000 is because they spun so many instances that costed that much to do what? To mine Bitcoin. So this is your targeted attacker. It's people that are going to steal your credentials to mine Bitcoin and to do all sorts of mischief. They didn't even try to go to the infrastructure, steal passwords or whatever. No, their path to monetization was Bitcoin. Let's just spin all the instances that we can. The only reason why this company detected this was because Amazon called them and said, look, we just froze your account because this is weird, so tell me if I should enable it or not. And so there's no amount of detection that's going to protect you against this. People are really passionate about mining Bitcoins, so be careful with that. And this brings me to the fact that, okay, now you've solved your secret sharing mechanism. But the reality of it is that we all know that every single one of you has passwords that you shouldn't have on your laptop. Why? Because it's really hard to share passwords around. And it's really hard to essentially bootstrap when you come to a company and essentially be up to speed with production access X or Y. However, people have to stop thinking of the laptop as the boundary for security. Your laptop should not have passwords, should not have credentials. It should have the minimum amount of credentials possible. And nothing that comes from your laptop should be allowed access to production without two-factor authentication. The reason for that is very simple. People tell me, Diogo, it's fine, I have full disk encryption. And I tell them, I had a friend that was on the Muni in San Francisco programming on his laptop, and somebody stole his laptop while it was unlocked. So full disk encryption doesn't help. Literally, somebody just came along and took his laptop, and he saw his laptop leaving the bus while open. So clearly, they had access to those passwords. So this happens. And even with full disk encryption, obviously it takes a sophisticated attacker, but there's tons of bugs with file vault and DMA access, direct memory accesses, like Inception, that allow you to plug into an external port and essentially steal all the passwords from RAM and then decrypt everything. So you should not be relying on laptops to do safe vault password storage. There's several solutions for that, and you should use something that is centralized and that allows your developers very easily to share credentials with each other. Hopefully something that does not actually give the password to your developer, something that abstracts the logging in to, for example, Amazon's console IAM. In terms of hashing passwords, I would like to ask again, a show of hands, who is storing username and passwords in their infrastructure in some place or another? A lot of people storing passwords. Who of these people are storing these passwords using not bcrypt? So using something else besides bcrypt? Shame on you. Shame on the people not using bcrypt, because it's the only possible answer when it comes to password hashing. So I'm just going to leave it there. Use bcrypt, use bcrypt, use bcrypt. Okay, so on to infrastructure mistakes. So mistakes that people do while designing and deploying their infrastructure. So the first one, and obviously I'm very biased on this one, but it's really, really hard right now to have an application or have an infrastructure where you're not nimble, where you can't update stuff, where you can't rotate your kernel, where you can't update your packages fast enough. I think something happened that was really interesting, which was a sequence of bugs this past year that really made us think about this. Think of Heartbleed. Think of shell shock, right? These bugs just immediately started running rampant with public exploits because they were so easy to exploit. It was to the point where shell shock, I saw attacks coming in 8 hours after the vulnerability was released. It was so easy to implement and to attack. 8 hours, we were seeing mass scans across all of our infrastructure. And what this tells you is that you have 8 hours to fix every single production system that is exposed to the internet. And now, honestly, which one of you has an infrastructure where in 8 hours or less, they can fix every single package, or they can restart all of their kernels? This doesn't exist. So you really have to strive to make sure that you're in a position where you can rotate this as fast as possible. And this is where I think containerization comes to play and really allows you to migrate applications and have the easy way to do updates and just redeploy the container, build it from scratch, and then immediately you have a patched infrastructure. But this is only going to start happening more and more, not less. So make sure that you can aim for the 8-hour mark, and you can update all of your packages across all of your hosts in 8 hours or less. Another thing that is interesting, that I see a mistake, is not having two-factor authentication from day one. Two-factor authentication nowadays is really easy. You have mobile applications with push notifications, you have Google Authenticator, you have PEM modules, you have every single way. There's literally no excuse for you not to implement this from day one. Even in stuff like SSH, you have the PEM modules that you can hook up. The hard part is when you have 2,000 engineers, and then you try to tell them, look, you can't use this thing anymore, and now you have to add this other factor. It is night and day the difference. If engineers come and are indoctrinated into your organization as security is something that we take seriously, and from day one, this is how you access production. Use two-factor authentication if you're using a website, using some centralized login system, or even if you're using SSH, you have to have two-factor authentication. And nobody complains, everybody's indoctrinated into the culture, and everything is fine. But now you go to Facebook. They had 2,000 people when they started rolling this out. So rolling out YubiKeys, which was what they did for two-factor, across every single engineer, it took a lot of effort. It was orders of magnitude harder than it had been just from day one, just to say, no, we're going to do something as simple as two-factor authentication on our SSH and have just Google Authenticator as second factor. So don't ruin this one. And directly related, some people tell me, Diogo, I don't need two-factor authentication because I'm doing IP validation on my firewall, and I actually only allow IPs from my corporate network to access my internal websites. And this is one of the other situations where you don't really know if you should laugh or cry, but the reality of this is that you should not be trusting IP validation for anything. And your corporate network should not be the security boundary. Production should protect itself. You should use strong mechanisms to protect from production from the internet, production from the internet, the same way that you protect production from the corporate network. So you have to assume that corporate network is malicious. Because if you don't, then you're essentially vulnerable to somebody just walking in and plugging in an Ethernet port, or just stealing a laptop and having wireless access to the wireless network. Or even a ton of people have a WPA shared password, right? Not even certificates are being used. So it's trivial to get access to your corporate network. Another mistake that I see very often, and I know this is laughable, but people don't have centralized logging. And the problem is that not only they don't have centralized logging, they only understand and realize they don't have centralized logging when they get hacked. So the moment they're trying to do incident response, they realize, oh, I'm not logging this, or oh, these logs were actually on the server that got hacked, and obviously the attacker removed them. So trivial things like this keep happening over and over and over again. And another mistake that I've seen that is terrible from an incident response perspective is having the clocks of your servers all over the place. It seems easy for you to have NTP synced on your server, and I know that internally you're laughing, this would never happen to me, but I can guarantee you there's going to be some server on your company that is not synced with NTP, And the reason why it's not synced with NTP is because it was some forgotten server that is probably not being actively managed and has some out-of-date packages, and that's the server that's going to be hacked because that's a server that nobody's caring about, and that's the server that you're going to need the NTP to be synced on, and that's a server that's not going to have NTP synced on. So these things are really important for you to figure out. And if you're using AWS or if you're using a similar system, make sure you're using something like CloudTrail. Just go enable it now, like something of the sort that gives you what happened on which machine, when, at what time, and something that is append only, that doesn't allow an attacker to come in and just change the logs. Another thing that I hear over and over again, or that I feel like people don't have as a big issue, is what I call the infrastructure cowboy complex. So people think that root is a right from God, that they were handed, that root is the thing that it should have access to every single server. I do not agree with this, not even one bit. You should have the use of sudo, the use of su, the use of root privileges as an alertable event. This should not be something that your engineers go around and use all the time. Should they have access to it for an emergency? Yes, they should. We should empower them to do the things that they need to do in an emergency. But that has to be an alertable event. And you have to graph sudo accesses in order to bring them down as time goes on. It is not okay that you have a 500 engineer infrastructure and everybody runs rampant with root. That is not cool. And not only that's not cool, that's going to be your doom, because it's a lot easier for an attacker to essentially do lateral movement and escalate in your infrastructure if every single one of your engineers has root access, and it's going to be a lot harder for you to detect that, because for you it's going to be normal behavior. Now we just use root, sudo su, like you did always. So make sure that root is an alertable event. And if you're not doing it, you make me a sad panda. HTTPS for service-to-service communication. So this is something that I think was really good that came out of the Snowden revelations, was that there was obviously some fiber tapping going on somewhere in the United States. And what this made people realize is that you should treat your data centers from each other. You should treat your links, your fiber optic links, as malicious. They were not. These wavelengths, this is dark fiber that I'm renting, so everybody thought we're fine. You're not. So every single service in your infrastructure should use S2S. So I know that this one is particularly hard to solve, and from a company just starting up, it is actually really hard to implement this and to have a CA infrastructure that is mature enough for you to be able to hand out certificates this way. But the reality of this is that this one is really, really, really painful to solve later on. Borderline impossible. There's very few companies that I know of that have been able to essentially go back and create infrastructure where engineers are used to deploying S2S, where engineers understand what S2S is, and where TLS certificates are something that is actually transparent in the organization and people are not actually scared of. And now we go into firewalls. So firewalls are these interesting pieces of hardware that for the longest time, every single security engineer that you know said you have to have one of these. And then at some point, somebody realized that stateful firewalls had some interesting characteristics, and so they started saying you should have a stateful firewall. Unfortunately, the reality is that stateful firewalls have outlived their usefulness. You should not be using a stateful firewall. I know this is kind of dramatic coming from a security engineer and somebody that is actually building these things at scale, but the reality of it is that there is no firewall that can withstand 100 gigabits of line rate or withstand the largest router. The largest router out there, if it has, I don't know, 48, 40 gig ports, you would have to buy hundreds of firewalls to actually keep up with that pace. And hundreds of firewalls are really expensive. Also, this is the wrong level of abstraction for you. Your security should be at the application level. I'm not saying that you should not be using network segmentation. What I'm saying is that your network segmentation should be focusing on large clusters and security zones, and definitely not being used or not using stateful firewalls. IP tables at the host level are totally fine. And if you have just some network ACLs on your routers or on your internal switches that segregate large zones, that is totally cool. You are not going to be able to scale with stateful firewalls anywhere. Ask the people from Facebook, ask the people from Google, none of those people are using in production stateful firewalls. And this brings me to my last topic, which is the last one, but it's not the least important. In particular, everybody knows that the way that people are being popped and the way people are being hacked is essentially using phishing. So they send some malicious PDF, some malicious JavaScript, or some malicious Java file, or something of the sort, and essentially your laptop gets compromised. And this is a huge issue. This is the easiest way of compromising a network. And I don't see any focus, especially from early stage startups, in protecting their own laptops. So the only thing that I would say is that there are simple things that you can do, something like a checklist, that can help you a ton, especially if you're starting up. Imagine a self-serve checklist for your employees that says the following. You should use Chrome. None of that Internet Explorer, none of that Firefox. You should use Chrome. Second thing, you should be using ad block extensions. If you're seeing ads, the likelihood of there being malware and malicious software or malicious JavaScript is actually really high. So you should definitely block those. You should disable Java. There are no legitimate uses for Java. Unfortunately, there's the 0.1% that actually needs Java, and in that case, you should use it inside a virtual machine, not actually enable it on the host. You should totally have Flash to be click to play. So Flash should just not like you pop up a page and immediately comes up and starts running. And full disk encryption is mandatory. I know that I said there are some caveats, but it's a lot better if a laptop gets stolen and it has full disk encryption than it doesn't. On the other hand, if it doesn't have full disk encryption, you get really good at password rotation, and that is actually a good thing. Every time a laptop gets compromised, you have to rotate every single production password, and therefore you become really good at it. It was actually a good exercise for you to have. Finally, you should know where your laptops are and when your phones are, so Find My Mac or something like Pray for Windows, and you should totally store passwords on password managers. The way that I tell new employees, and I did this every single week for years, I had a presentation to every single new employee of Square, and one of the things that I always told them was, if you know your password, then it's a bad password. If you know it, it's a bad password. The number of passwords that you actually will have to know, you can count them by the numbers of your fingers. It's the password to access your laptop. It's the unlock key for your phone. It's very limited. It's a password to your password manager. But other than that, it's very easy for you to memorize 5 good passwords. It's very hard for you to memorize 200 good passwords. So if you don't know your password, or if you do know your password, then that's a bad password. So in summary, thank you for staying here so late and to hear my ramblings around security. But I really think there are, and I've seen tons of security issues that come over and over again in these startups. And these not are normal security issues. The ones that I demonstrated to you or that I showed you are really, really hard to essentially fix later on. Some of these mistakes are a lot more costly than others. And you have to take the long view and bring in a security engineer early on that is able to help you distinguish between what is a mistake or what is something that you have to invest time on or what is something that you can push maybe a little bit further ahead and then fix later. So really, a reminder, you should not bring security engineers that are just there to say no and there to essentially send passive-aggressive emails. Hire a security engineer that ships. Thank you very much.
I would take a small courtesy bow if I was you now. Any questions to Diogo?
I was expecting a lot of questions. Shoot.
There must be a lot of questions. Oh, there is one. From Arnoud.
How do you have any tips of keeping up to date with security best practices?
That's a great question. The question is keeping up to date with security best practices. I think, unfortunately, the best answer to that is Twitter. The best way for you to keep track of what's happening is to follow the right people on Twitter. There are people that are really good on Twitter. They're really easy to find. They're also very vocal, so the amount of spam is actually really high on their lists. But if you keep up with them, you're actually going to see a lot of good recommendations. I think it's okay for you to talk to vendors and ask them for their security best practices and to actually ask them for their non-marketing material around security. And that really allows you to distinguish the companies that take it seriously and the companies that don't take it seriously. But I would say that unfortunately, the best that we have is online resources, and Twitter feeds are really good for you to keep up to date with what people are working on. But that's a great question. Don't be shy. Ask me whatever you like.
I have a question related to Docker and security.
Sure.
Docker exposes environmental variables, and most of the passwords for external database or whatever are also exposed in environmental variables. How can that be secured? Like, for example, if the server is compromised, how can we secure the environmental variables?
It's a great question. So around our environmental variables. So it turns out that I'm actually a big believer of passwords and secrets should never hit an environmental variable. Unfortunately, that's something that Unix people do and that we've been doing for years, so it's really hard to shake. But the problem is that environmental variables get logged everywhere. You fork a process or you exec a process, and that process inherits all the environmental variables. So if you're executing echo, now echo has access to every single credential that you have, Oz, et cetera, et cetera. So I agree 100%, you should not be using secrets on environmental variables. For Docker specifically, unfortunately, there's no condoned or no flashed out security option for how to distribute your secrets. So the answers, or the same answer applies to if you're running your infrastructure. I would say that there's very good, especially lately in the past 2 months, there have been 3 very good systems that were open sourced. So one of them, Keywizz, was open sourced from Square. It's a very cool system. I worked on it, so disclaimer, I'm obviously biased on this topic. It's amazing. The second one was by HashiCorp, something called Vault. And the third one was something by Codahail that we all know and love called Sneaker. The way that they fix it, in a particular case of Square, the way that we did it was we actually had this really cool idea, which was in every host, we run a FuseFS mount point that essentially virtualizes the file system. So from your application's perspective, you actually just have access to a bunch of files that have a password. But in the back end, this is only running in memory and calling a centralized server that has all of your secrets. And this FuseFS mount point actually keeps all the secrets in memory, and it has a flag that it never writes them to disk. So if somebody shuts down the machine and takes it home, there's virtually no secrets on any of your hosts. And so this is, for example, a good way for you to implement this, and it would actually be really easy for you to deploy something like this for Docker. More questions around people being compromised and mining Bitcoin? Everybody just wants to go for drinks.
Now ask questions to Diogo. Yeah.
What was that? Yes.
Yeah.
Please ask me questions during the drinks.
We definitely will.
The more drinks, the better the answer. Thank you very much.
Let me start you off, Diogo.
Okay.
Thank you much for your presentation.